Why is there stuff already up on the board? You can probably guess why. Going to do some coupling reactions here using cuprate, which we are familiar with. But coupling is just taking really double bonds, putting them together, we get conjugation. It's great. There's no real like mechanisms we need to know, which is good. It's just basically putting two things together. Let's start out with cuprate. We're going to do the whiteboard examples, which at this point are not filled out yet. Once she does fill them out, make sure to check them, make sure they match these. Hopefully they do, they should. I always say you use the whiteboard first, make your own problems, test others second, and then as a last resort, if you have to, watch these videos and go to SI. So cuprate, we've dealt with cuprate before. The only change we're really making is we're making our R group is going to be like a double bond. So the example we're given on the whiteboard, something like this, and we're reacting it with cuprate. And she writes it like this and puts our two carbons in parentheses. Just to write that out would look like something like this, where this is our R group. Okay. All I do, R group, here's where the bromine's a good leaving group. R group, leaving group. Goes my leaving group, and I put my R group where my leaving group was. That's it. My answer is conjugated. That's good. Alternating double bonds. I see that. Probably wrote down the right thing. That's all. She also gives the example of like an ethyl group, cuprate, and yeah, it's not even double bonds, so I don't know why this is really even included, but we're also given leaving group there. Now our R groups for our cuprates are R minus, really strong nucleophile. They're going to perform SN2 reactions. If you remember, SN2 does not work with tertiary alkyl halides because tertiary alkyl halides give very stable carbocations, which will favor SN1. Don't know why it's on there, but that's the explanation of why this one is no reaction on the whiteboard. R minus really strong, going to favor SN2. SN2 doesn't work tertiary, it's going to favor SN1. Okay, next up, Suzuki. Suzuki coupling is going to be when we have boron, and boron's just going to leave, it's just going to go away, but that's just how you recognize it. The main thing is that our stereochemistry, the way that our double bonds are oriented, are going to be conserved. Same thing with Heck. We'll do Suzuki first. We'll see that it has boron in it. Boron. Okay, similar thing here. I get rid of my leaving group, I'll get rid of bromine, or rid of boron, and I take what's left and I put them together. The orientation of that double bond should be conserved. When I say that, I see that I have, if I look at my alkyl halide in this case, I can look at my alkyl halide and say that this is E conformation. So when I take that and I bond it over here, it should remain E, okay? So boron and its substituents, gone. So that bond between boron and the actual organic part of it, I say actual organic part, whether it is or not, I don't really care. I get rid of boron. I get rid of my leaving group. So where boron was is my leaving group. I bond them together. So here's this carbon, and on that carbon I have a methyl group, double bond, and I have I have E conformation, opposite sides. That is conserved, okay? Now, if I had at the beginning something like this, I would take that and I would add it over here, and I would get the Z conformation. This part will stay conserved when I add it on. That is it. What's a little bit weird is that if I conserve the E conformation and I put it over here, we actually got the Z product. And when I use the Z reactant, and I put it over here, notice now we actually have the our large groups are on. I should begin. So I'm kind of switching these up. Yeah. So even though we had the E, and this isn't too important, it's just something to recognize. We had the E reactant and we had this. Our methyl and benzyl groups are on the same side, whereas when we use the Z reactant, we got our benzyl and our hydrogen on the same side. So not too important, but just know that these will stay conserved. Notice, this is the same as that, this same as that. And all we do is we just put them together. That's all. Pretty much the same for Heck reaction. Stereochemistry is going to be conserved. Example we're given. Whiteboard, this plus so here I notice I have Z conformation with my leaving group, so that should stay conserved. I have a terminal alkene here. I should expect that in Heck. So boron was our determining factor for Suzuki. One terminal alkene will be our determining factor for Heck. And when we get to metathesis, that will be 2 terminal alkenes. I take my, and this should probably be, I take my leaving group, I take my terminal alkene, I put them together, I bond them together, and think of it, when we do that, we'll be taking double bond, bonding them together with a single bond will be conjugated. To make this visually easier on us, I'm going to take this and flip it around. That way my groups that are attaching are already close together. So I'm just going to take that and flip it around. Just a mirror image, kind of. Yeah. Okay. So leaving group, disappear, and I take this and I add it onto here. Bond it onto there. That is all. That's it. This should stay Z. It was Z before, it should stay Z. Okay? This is going to always be what we're adding to is going to stay in our trans, our E conformation. So I should have a bond going up and that should be my final product. So I had this to start out, and notice that is still Z, this alkene is Z, and our other material will always be E, because we have two hydrogens there to really react with. One that's going to give us E, one that's going to give us Z. We're going to select for the one that will keep this one E when we can, and then it's going to be conserved with our alkyl halide. Don't overthink it. Erase your leaving group and put the things together. That's really all it is, okay? I can talk as much as I want in these videos and I make them too long anyway. Erase your leaving group and put the things together. Ta-da! Conjugated, 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 conjugated. I write that down, I should know I did pretty good. Last one.